Okay, so welcome back to our video. So here's a 2011 AIME, the American Invitational Mathematics Examination, Part 1, and this is question number 9. And this is here we have a little algebra trigonometry hybrid problem, and that is suppose that x falls between the closed interval from 0 to pi over 2, and we have that the log base of 24 sine x of 24 cosine of x is equal to 3 over 2. We want to find the value of 24 cotangent square of x. So aligning together algebra and trigonometry together. So it's again, it's just everything that you learn from high school. And that typically with AIME problems, they're basically the problems at that level, specifically around the high school level, sometimes even college levels, depending on like the year. But I don't think there was a time I found a calculus problem. I know generally they like to test you on algebra, number theory, and geometry, especially. Combinatorics too, I believe, as well. But this is actually not as bad as it looks. Again, it's manipulation, just how algebra class usually teach you to get a little creative and solve stuff. And of course, we have that with a log base, so we have to be careful with that definition as well. So anyway, not much to be said because it's I think it's pretty self-explanatory. So let's actually just jump right in. So first, we see that by definition, given log base 24 sine x, 24 cosine of x equals 3 over 2. So by definition, that says that the constant raised to the exponent is going to equal the input. So with this, let's actually use that definition, write this as the following. So we have, that's the 2 is the square, and then 3 goes inside of the input, inside the radical. So in other words, we have the square root of 24 cubed times sine cube of x is going to equal 24 cosine of x. So with this, let's actually square both sides. So that's nice to say that the square root cancels each other out, and sine cube of x is going to equal to 24 square, and then cosine square of x. Then nicely that we can see that we can just divide 24 square to both sides. So we're just left with a single quantity of 24 on the left-hand side. Sine square of x, or sine cube of x, is equal to cosine square of x. Nicely done. Now let's do a little bit of some manipulation and rewrite cosine square of x from the fundamental theorem of trigonometry, which says that cosine square of x plus sine square of x is equal to 1. But if we just solve for cosine square of x by its own, we know that this is just going to equal to simply just 1, and then subtract sine square of x. Great. So with this, let's actually just plug this back into that substitution over here. So far we have established that 24 times sine cube of x is equal to 1 subtract sine square of x. Okay. And so let's actually get everything by itself. So just like we're solving just a little equation. Well, specifically we have a cubic equation to this degree, trigonometric. So 24 sine cube of x. Add this with sine square of x, then subtract 1 is going to just equal 0. So one might think, how would we proceed forward with this? Couldn't we, because it's, again, that this is actually a cubic function, so it's actually not that easy to see that you can actually, apply quadratic formula. Again, that's applying for, polynomials of, the second degree. Well, and it's also, we have a square, or we have a cube square. We don't have anything in the leading coefficient or leading degree of 1, and then a constant. We can actually apply the rational roots theorem. And I'm not really going to go into the whole exercise of that. I can leave that as an exercise for you guys. You'll get that applying this, you're going to get 3 different solutions. You're actually going to get one solution that actually satisfies the following. The other 2 solutions are imaginary solutions, but yet if you were to plug this back into, apply with that whole application, you're not going to get any solutions or roots out of that. So we have that the only root is that sine square, or sine of x, is just equal to 1 over 3. And then if I were to take the inverse of both sides for sine, or inverse sine, so that means I have x on its own on the left-hand side. So I have that x is equal to sine inverse of 1 over 3, which I can't give you the exact radians, but approximately that's averaging around 19.44 degrees, I believe. But what that entails is that, yes, this actually does fall between this interval from x from 0 to pi over 2. We know that pi over 2 in radians degrees, it's 90 degrees, so it does fall in there. So it does satisfy. So how do we proceed from here? So sine of x equals 1 over 3 is our root. What do we do here? Well, we can actually just apply the Pythagorean theorem. So suppose that we have that x, sine of x is 1 over 3. So we have 1 here, 3 here, because it's opposite over hypotenuse. So we want to find the unknown. So we just, again, apply Pythagorean theorem. I'll just call this b squared equals 3 squared. So I have 1 plus b squared equals 9, subtract 1. We have b squared is equal to 8. Then take the square root of both sides. We were only dealing with, the positive because it's length. So it's 2 times the square root of 2. This means that cosine of x is going to equal 2 times the square root of 2 divided by 3. Now, if I square both sides, so I have cosine squared of x is equal to 8 divided by 9. Okay, so that's great. But what does this have to do with it? What does this have to do with anything? Well, recall by definition, cotangent square of x is cosine square of x divided by sine square of x. So what this means is that we just go back to what we're trying to solve. So 24 cotangent square of x is basically just equal to 24 and then times cosine square of x divided by sine square of x. Then we see that if just plug this back in, square those, so we have this is going to be 8 over 9 and then divided by 1 over 9. You solve all this out, we're going to get that this is actually just equal to 24 times 8 over here, which multiply that out, you're going to get that this is just equal to 192. And just like that, that completes it. If you want to take this and take things a little more of a shorter / easier way, what you can do is that so if we go back to the original equation, well, specifically the 24, here, I'll put it this way. The 24 sine cube of x equals cosine square of x. What we can do here is you can actually just multiply a 24 divided by sine square of x to both sides. And then we see that, of course, 24 cosine square of x divided by sine square of x, that's what we want to calculate. We do it from over here. I forgot that there's supposed to be a 24 on this side here. So actually, let me put this as a square. So that's great. So with this is actually going to give us 576. Then sine squares will cancel. So I have sine of x and then equals 24 cotangent square of x, which is what we want to solve. We know that sine square of x is equal to 1 over 3. So we see that 576 multiplied by 1 over 3 is indeed just equal to 192, just like we have solved earlier. So if you want to use that approach, well, the easier way you want to put it that way, sure. And either way works, but it guarantees you the same solutions with those methods. So yeah, that's pretty cool if you ask me.